Have you ever wondered what it would be like to step foot on the moon again, after more than half a century since the last human visit? In the mid-2020s, that dream might just become a reality, thanks to NASA's Artemis program. This ambitious initiative aims to bring humans back to the moon. But it's not just about planting a flag and leaving footprints. The Artemis program is all about sustainable lunar exploration. Imagine scientists and astronauts living and working on the moon for extended periods, conducting research, and unraveling the mysteries of our closest celestial neighbor. It's about setting up a lunar base, a home away from home, right there on the moon's surface. But there's more. The Artemis program also plans to establish the Gateway, a space station in lunar orbit. This lunar outpost will serve as a hub for astronauts traveling to and from the moon, providing a stepping stone for further space exploration. Picture this. A space station orbiting the moon, like a celestial rest stop, where astronauts can refuel and prepare for their next big adventure. But the moon is just the beginning. The Artemis program is a stepping stone, laying the groundwork for even more ambitious endeavors. By learning to live on the moon, we're preparing for the next giant leap, sending humans to Mars. The knowledge and experience gained from the Artemis program will be invaluable in planning and executing future crewed missions to the Red Planet. The Artemis program is more than just a return to the moon. It's a bold new chapter in human space exploration, one that will push the boundaries of our capabilities and expand our understanding of the cosmos. As we set our sights on the moon once again, we're also gazing further into the cosmos, toward our red neighbor. Because who knows? The first person to set foot on Mars might just be listening to this right now. Imagine a distant future where humans call not just one but two planets home. Sounds far-fetched? Not to the scientists and engineers working tirelessly on Mars exploration. Our curiosity has driven us to the red planet, Mars, a world of intrigue and mystery. NASA's Perseverance rover is playing a pivotal role in our understanding of Mars, its mission to seek signs of past microbial life. As it roams the Martian surface, it's investigating the planet's geology and climate, aiming to piece together its history and determine if the planet once harbored conditions suitable for life. But the intrigue doesn't stop at exploration. SpaceX, the private spaceflight company led by Elon Musk, has grand visions for the red planet. They're not just looking to visit Mars, they're planning to build a self-sustaining city with 1 million inhabitants by the mid-21st century. An ambitious vision, indeed. But if there's anything we've learned from our journey into space, it's that human determination knows no bounds. Of course, making Mars habitable won't be easy. That's where the concept of terraforming comes in. Terraforming is the hypothetical process of deliberately modifying a planet's atmosphere, temperature, and ecology to make it habitable for Earth life. It's like taking Mars and giving it an Earth-like makeover. While it's currently the stuff of science fiction, researchers are exploring the concept through advanced simulations and theoretical research. One such idea involves the use of mirrors to warm the planet, while another proposes the introduction of photosynthetic organisms to produce oxygen. It's a monumental challenge, but one that could potentially turn Mars into a second home for humanity. While Mars captivates our imaginations, the search for life extends beyond our solar system. As we venture further into space, we're not just exploring new worlds. We're redefining our place in the universe, learning more about our own planet, and perhaps, even taking the first steps towards becoming a multiplanetary species. What if we told you that the search for extraterrestrial life is not confined to the realms of science fiction, but is a significant part of modern-day astronomy? Astrobiology, the study of life in the universe, is a fascinating field that is constantly evolving. It blends the disciplines of astronomy, biology, and geology to understand the potential for life beyond Earth. One of the key areas of focus in astrobiology is the study of exoplanets. Planets that orbit stars outside our solar system. Astronomers are using advanced techniques to study the atmospheres of these distant worlds. They're looking for biosignatures, specific chemical combinations that could indicate the presence of life. By analyzing the light that passes through an exoplanet's atmosphere, scientists can identify gases like oxygen, methane, and water vapor, elements that, on Earth, are associated with life. But how do we get this data? Well, that's where missions like the James Webb Space Telescope come in. The successor to the Hubble Space Telescope, the James Webb is designed to peer into the distant corners of the universe, and its advanced instruments will provide unprecedented data about exoplanet atmospheres. The telescope's spectrographs can split the light from a star or planet, into its component colors, creating a spectrum that can reveal the presence of specific molecules. This will allow us to detect potential biosignatures on distant exoplanets, bringing us one step closer to answering the question of whether we are alone in the universe. The exploration of exoplanets and the search for extraterrestrial life is a complex and challenging endeavor, but it is one that continues to captivate us. The promise of discovering a world that could harbor life, the possibility of answering the age-old question, "Are we alone?" drives us to push the boundaries of our understanding, to reach farther into the cosmos. Our quest to explore the cosmos has, however, led to an unexpected problem: space debris. As we reach for the stars, we must also address the growing challenge of space debris that threatens the sustainability of space activities. As we propel further into the cosmos, our activities have generated a cloud of fragments circling our planet, a testament to our technological progress but also a potential hazard for our continued exploration. This space junk, as it's often called, is not just a nuisance, it's a genuine threat. From defunct satellites to spent rocket stages, from tiny paint flakes to shards of metal, these fragments, traveling at incredible speeds, can cause catastrophic damage to both manned and unmanned spacecraft. But fear not, because we're not letting this challenge go unaddressed. Enter the innovative field of space debris management. This is the science and engineering of keeping our orbital highways clear for safe navigation. Scientists and engineers worldwide are developing advanced technologies to tackle this issue. Some are designing new satellites with self-destruction mechanisms that will allow them to burn up in the Earth's atmosphere at the end of their operational lives. Others are working on more active solutions like debris removal systems. These could be anything from nets and harpoons to robotic arms, all designed to capture and safely dispose of space junk. Another crucial aspect is tracking. Ground-based radars and telescopes are keeping a careful eye on the thousands of objects in orbit, predicting their paths, and issuing warnings if collisions seem likely. This kind of space traffic management is becoming increasingly important as our activities in space continue to grow. The aim of all these efforts? To ensure that our journey into the cosmos can continue unabated. To make sure that the path to the stars remains open for the astronauts of today and the explorers of tomorrow. Our journey into the cosmos is not without its challenges, but with every hurdle, we learn, adapt, and continue to reach for the stars. Today, we've taken a voyage through some of the most exciting developments in space exploration. We've journeyed from the moon to Mars and beyond, peering into the depths of the cosmos, and addressing some of the challenges we face in our quest to explore the universe. We began our journey with NASA's Artemis program, a bold initiative that aims to return humans to the moon by the mid-2020s. This program isn't just about setting foot on the lunar surface again, it's about sustainable exploration, about establishing a space station in lunar orbit, the Gateway, which will serve as a stepping stone for future crewed missions to Mars. From the moon, we journeyed to Mars, a world that fascinates us with its potential for past and future life. Through the tireless work of rovers like Perseverance, we're actively searching for signs of past microbial life on the red planet. And looking into the future, visions of terraforming Mars, of making it more Earth-like, are no longer confined to the realm of science fiction. These are real goals that scientists and engineers are working on right now. Our voyage continued beyond our solar system to the study of astrobiology and exoplanets. The search for extraterrestrial life is extending its reach, with astronomers using advanced techniques to probe the atmospheres of distant exoplanets looking for biosignatures. The launch of the James Webb Space Telescope will greatly enhance our ability to study these far-flung worlds. Finally, we touched on the critical issue of space debris management. As our activities in space increase, we must develop advanced technologies for tracking, mitigating, and removing space debris to ensure the sustainability of our endeavors and prevent potentially catastrophic collisions. Each of these areas, from lunar exploration to exoplanet studies, plays a crucial role in our ongoing quest to explore the cosmos. Imagine the possibility of extracting and utilizing resources directly from celestial bodies like the Moon or Mars. This is the concept of in situ resource utilization, or ISRU. But what exactly does this mean, and why is it so crucial for our future in space? Let's break it down. In situ is a Latin phrase that literally translates to in place. Combine this with resource utilization, and you have a concept that involves using materials found in a location for practical purposes. In the context of space exploration, ISRU refers to the practice of harvesting and utilizing resources found on other planets. moons, or asteroids. Now you might be asking yourself, why is ISRU so important for long-duration space missions? Well, consider this. The cost of launching 1 kilogram of material from Earth to space is astronomically high. If we can reduce the amount of material we need to launch from Earth by utilizing resources already available in space, we can significantly cut down on mission costs. But the benefits of ISRU go beyond just cost savings. It also means that astronauts could potentially live off the land during long-term missions or stays on other planets or moons. For instance, water ice found on the Moon or Mars could be used for life support systems, providing drinking water and breathable oxygen. It could also be converted into hydrogen and oxygen, the components of rocket fuel, enabling the production of fuel for return journeys or further space exploration. So in essence, ISRU would not only make space missions more economically viable, but it could also increase their duration, reach, and safety. It's a game changer that could turn science fiction into science fact, allowing us to explore the farthest corners of our solar system and beyond. In Situ resource utilization takes us one step closer to being a spacefaring civilization by enabling us to utilize resources directly from celestial bodies. Quantum communication, a concept that promises ultra-secure, unhackable communication, is being tested for use between Earth and space-based platforms. This sophisticated technology has the potential to revolutionize how we transmit information in space, providing unparalleled security and reliability. Diving into the world of quantum physics, quantum communication is based on the principles of quantum entanglement and quantum superposition. These principles allow for the creation of communication links that are fundamentally secure, as any attempt to intercept or tamper with the transmission would immediately alert the sender and receiver. But what makes quantum communication so special? Well, imagine a communication system so secure that even the most advanced hacking tools would be rendered useless. This is because the very nature of quantum data makes it impossible to intercept without detection. It's like having a conversation in a language that only you and the person you're talking to understand. And if anyone else tries to listen in, you'd instantly know. Today, researchers are conducting experiments to test the feasibility of quantum communication in space. One such experiment involves sending entangled photons from a ground station on Earth to a satellite in space. The goal is to establish a quantum link that could enable ultra-secure, unhackable communication over long distances. This could be a game-changer for space missions, where secure and reliable communication is paramount. The challenges are significant, though. Quantum communication requires maintaining the delicate state of entangled particles over vast distances and through the Earth's atmosphere. But scientists are optimistic. As technology advances, solutions to these challenges are emerging, bringing us closer to realizing the potential of quantum communication in space. This is not just about secure communication, though. Quantum communication could also enhance the precision of GPS systems, improve the accuracy of remote sensing, and enable new forms of space-based quantum computing. Quantum communication could revolutionize how we transmit information in space, providing unparalleled security. It's a glimpse into a future where our space missions are safer, more secure, and more efficient. A future where the mysteries of the cosmos are within our grasp. Artificial intelligence is not just a concept for Earth, it's making waves in space too, playing a crucial role in autonomous navigation, data analysis, and decision-making for spacecraft. Imagine a space mission where the spacecraft can think for itself, make decisions, and adapt to unforeseen circumstances. That's not a plot from a sci-fi movie, it's today's reality. Artificial intelligence, or AI, is revolutionizing space exploration. In the vastness of space, where communication delays can take minutes or even hours, autonomous navigation becomes crucial. AI systems on spacecraft can process enormous amounts of data from onboard sensors in real time, allowing them to make split-second decisions. Whether it's dodging a piece of space debris or adjusting a trajectory for maximum fuel efficiency, these AI systems ensure the safety and success of the mission. But AI's role extends beyond just navigation. It is also instrumental in data analysis. Spacecraft are equipped with a plethora of scientific instruments, each generating a vast volume of data. Analyzing this data manually would be a daunting, if not impossible, task. AI comes to the rescue by sifting through this data, identifying patterns, and extracting valuable insights. This not only saves time but also enables us to discover phenomena that might otherwise go unnoticed. AI also guides the decision-making process for spacecraft. When faced with an unexpected event, such as a sudden storm on Mars or a malfunctioning instrument, AI can assess the situation, weigh the options, and choose the best course of action. This capability is particularly valuable in long-duration missions where immediate human intervention might not be possible. Moreover, AI optimizes mission trajectories. It calculates the best route for a spacecraft to take, considering factors like fuel efficiency, mission objectives, and safety. This allows us to explore more of the cosmos while using fewer resources. With AI, we are not just exploring space more efficiently, but also more intelligently. As we continue to push the boundaries of space exploration, the role of AI is set to become even more pivotal. It's not just about reaching new frontiers, it's about understanding them too. The concept of long-term space habitats and colonies is no longer science fiction. It's becoming a reality with more sophisticated designs incorporating closed-loop life support systems, radiation shielding, and psychological considerations. Imagine a time, not too distant from now, where we've established habitats, even whole colonies, beyond the confines of our home planet. It's an exciting prospect, isn't it? But how do we get there? What considerations must we take into account to make this dream a reality? Firstly, let's talk about life support. While the vacuum of space is not conducive to human life, closed-loop life support systems offer a solution. These systems recycle everything, from the air we breathe to the water we drink, even waste. Nothing is thrown away. It's the ultimate in sustainability and a necessity when living in space, where resources are scarce. Next, we must consider radiation. Without the protection of Earth's magnetic field, astronauts are exposed to harmful cosmic rays. To combat this, researchers are developing innovative radiation shielding techniques. These could range from traditional physical shields to more futuristic concepts like magnetic force fields. But it's not just about surviving in space, it's about thriving. Psychological considerations are paramount for long-term space habitation. Can you imagine being confined to a small space far from home for months, even years at a time? It's a daunting prospect. So, habitats and colonies must be designed with living spaces that promote mental well-being. They should include communal areas for socializing and private spaces for alone time, and windows are a must, so inhabitants can gaze upon the stars and the distant glow of Earth. In conclusion, designing and building habitats and colonies in space is a complex endeavor, requiring a marriage of various fields of science and engineering. But the payoff is immense. It's the next step in our journey as a spacefaring species, and it's within our reach. Space habitats and colonies are the future of human space exploration, and they're closer to reality than you might think. The future of space exploration is a fascinating blend of disciplines: astronomy, engineering, biology, computer science, and more. This interdisciplinary nature is a testament to our insatiable curiosity and our relentless pursuit of knowledge. Each discipline brings a unique perspective and a unique set of tools to the table. Astronomers provide us with a roadmap of the cosmos, engineers build the spacecraft to traverse it, biologists help us understand how life can survive and thrive in space, and computer scientists design the systems that make these missions possible. As we delve deeper into the intricacies of space exploration, we see the emergence of new technologies and methodologies. Resource utilization and in situ manufacturing are becoming crucial for long-duration space missions. By harnessing the resources available on celestial bodies, we can reduce the need for supplies from Earth and create sustainable ecosystems in space. Quantum communication is another exciting development. Offering unparalleled security for transmitting information, it could enable unhackable and ultra-secure communication between Earth and space-based platforms. Artificial intelligence and autonomous systems are revolutionizing the way we navigate and operate in space. Advanced AI systems can react to unforeseen events, optimize mission trajectories, and conduct science experiments more efficiently. And then, there are concepts for long-term space habitats and colonies. These sophisticated designs incorporate closed-loop life support systems, radiation shielding, and psychological considerations to ensure the well-being of inhabitants during extended missions or colonization efforts. All these advancements are expanding our capabilities and understanding of the universe. They are redefining what's possible and opening up new frontiers for exploration. As technology evolves, so does our reach into the cosmos. So, delve deeper, learn more about these technologies and their implications for space exploration. The universe is waiting. As we continue to uncover the mysteries of the universe, one thing remains certain: The journey of discovery is just as important as the discoveries themselves. Until next time, keep looking up and remember, the truth is out there.